I'd like to talk about plastics and why it's probably the worst building material of all. I will go into the detail on the different types of resins used in plastics so you can identify it based on the resin identification code, and talk about adverse health effects. And then Raphael's going to come in and talk about advantages and disadvantages and then give his rating, which I can guarantee you is going to be low. So what is plastic? Well, plastic consists of a wide range of synthetic or semi-synthetic organic or carbon-containing compounds, which means most of it's petrochemicals. You do have bioplastics coming onto the market and they're showing some promise, but for now the majority of plastics, which is more than 99% of plastics on the market, are derived from petrochemicals. And they can be moulded into any shape. I mean, let's face it, there are a lot of advantages of plastics, which Raph will go into. Incredibly diverse, relatively strong, and can be moulded into any shape, and they're lightweight and they don't break, but you know, the adverse health effects are significant enough that they're having a catastrophe effect on the planet and on human health. So the bioplastics are derived from renewable sources like vegetable fats and oils, cornstarch, and even microorganisms, but they account for less than 0.5% of all the plastics currently manufactured on the planet. So we need a lot of development in this field to be able to replace all the toxic plastics that are currently available. And I really wanted to start with the Great Pacific Garbage Patch, which is a floating landfill of around 1 million square kilometres of plastics between Hawaii and California. It is a disaster on human health without any shadow of a doubt, and this eclipses any of the adverse health effects, because as a result of this, when you have plastics in the ocean, what's happening is the UV from the sun breaks it down into microbeads, into very small plastics, which have now infiltrated just about every fish. Of course, it goes up the food chain, and then of course we consume this fish. So we're dumping our waste into the environment and the oceans, and we're ultimately eating that waste. And of course it's having devastating impacts on marine life and on human health. Around 8 million tonnes of plastic are dumped into the oceans every single year, according to the National Geographic, and it takes around 400 years, in some cases 4,000 years, for biodegradable plastics and recyclable plastics to be degraded, which is just shocking. So let's go into the different types of plastics, and we identify this based on the resin identification code. Some people refer to this as the recycling number. Basically, it identifies the dominant resin in that plastic. However, when we went to manufacture our own plastic bottles many years ago, I would never do that now, we wanted to get polypropylene plastic. And the manufacturer in Asia stated that you can't use just polypropylene, you have to add other chemicals to the plastic to make it transparent, to make it more flexible, to make it stronger, because it's not industry practice to use one type of resin in a plastic. So the resin identification code actually only provides one of the dominant resins used, not all of the chemicals that can be used in that type of plastic. So many mixtures of additives can be added that you would never know about unless you were there at the manufacturing plant watching them putting it in there. Because of trade secrecy laws, they don't have to identify all those other chemicals. So let's start with polyethylene terephthalate, or PET or PETE. It is considered to be the most recyclable plastic in the world. It accounts for at least 95% of all your bottled water. In fact, your bottled water, disposable bottled water, are accounting for most of the plastic in our oceans. And for this reason alone, I strongly suggest you don't use plastic bottled water for many reasons, but especially for the environmental waste, that you use stainless steel and reuse that, and use, of course, a water filter to put into your stainless steel bottles. It is the most recyclable plastic, and yet most of that, only 9% of all recyclable plastics are recycled according to the latest research. So 91% of the recyclable plastics aren't being recycled, and that's a problem. It's mainly used for primarily disposable water bottles, but also for food packaging like milk, soft drinks, products, oven-proof trays. It may contain antimony, which is a metal used during its manufacture, and that can leach into the water when you keep your water bottle, for example, in a car when it exceeds 60 degrees. It's often found in many of these oven-proof trays when you heat this type of plastic, that it can leach antimony again into the food. So again, plastics, you shouldn't be heating your foods in, you shouldn't even be putting your beverages in there. And there are concerns it could leach endocrine disrupting chemicals or hormone disrupting chemicals. Now, if virgin PET is used, it's unlikely to be a source of hormone disrupting chemicals. But if it's recycled or made from recycled materials, if that was recycled from a shampoo or a moisturiser or a personal care product that contained a perfume, then the phthalates in that perfume can embed themselves in the plastic, and that can then go into that water bottle. So this is why you don't know when you buy a water bottle whether it's going to have recycled or virgin PET, and that's another reason why you shouldn't be drinking from these plastics. The second type of plastic, or number 2 resin identification code, is high density polyethylene, or HDPE. It is a hard plastic, it is recyclable. Again, most recyclable plastics aren't recycled. It's mainly used in plastic bottles that you'll often find for children, that are marketed to children and adults. Milk cartons, commercial juices, margarine tubs, detergents, and a lot of personal care products, and even toys and shopping bags. It can be recycled into tables and into roadside curbs, benches, white plastic peanuts used in packaging, and it's not considered to leach any form of hormone disrupting chemical. The third plastic, probably the worst plastic, is polyvinyl chloride, and Raf will go into that when it comes to plastics. PVC contains phthalates, which can leach into anything that it's contained in. We know with vinyl flooring that it emits considerable levels of phthalates because it's not bound to the plastic. These phthalates can then get into household dust, and there have been some interesting studies correlating women with breast cancer with high levels of phthalates in their household dust because of their vinyl flooring. PVC is used in food packaging like cling wraps, storage containers and juice bottles, cosmetics, building materials like shower curtains, water pipes and flooring. Sex toys are often PVC, and you can smell that, and that's obviously, you don't want that anywhere near your body or in your body. Waterproof clothing, medical equipment like the IV bags are often PVC, and they're starting to look at the phthalate exposures by using, when you get blood transfusions because of these PVC based bags. Car interiors are commonly contain high levels of these phthalates, and that's a real problem. These phthalates could be anything from diethylhexyl phthalate, benzobutyl phthalate. There are over 20 phthalates known, and many of these are used in polyvinyl chloride. Again, water pipes would be a big concern. When I did a lecture in the US, a man came up to me afterwards and said, did I know that most of the domestic pipes used in America are PVC, whereas we tend to use polypipe, polyethylene, polypropylene pipe as our domestic supply. They're using PVC. Now, the problem with PVC, of course, is that being a hormone disrupting chemical, they have correlated with obesogens and obesity, especially in children. So that again is a problem. We also know that the old types of PVC can contain lead and cadmium stabilisers, which can leach in the water supply or leach from the vinyl building materials. And of course, when they're burnt, they release dioxins, which are considered to be the most carcinogenic chemical known to man. So that's why you never burn plastics. And of course, they leach phthalates. The third type of plastic is low density polyethylene, or LDPE. It is not recyclable. It's soft and quite flexible. It's used generally for garbage and shopping bags primarily. It can be used also for sports water bottles, and it's not considered to be a form of hormone disrupting chemicals. For number 5, it's polypropylene, not recyclable, quite a rigid plastic. I've noticed some of the baby bottles can be made from this plastic. It's used a lot in ice cream and yogurt containers, as well as margarine tubs and drinking straws. Some types of water pipes and drinking water bottles may contain polypropylene. It is not considered to contain hormone disrupting chemicals. Number 6, real problem, polystyrene. Again, it contains nonylphenols, which are hormone-disrupting chemicals. In 1987, 2 cell biologists at Tufts University, Anna Soto and Carla Sonnenschein, were examining the relationship between breast cancer and estrogen hormone. They got a whole lot of breast cancer cells, put them in the test tubes, and the breast cancer cells multiplied if they were exposed to estrogen hormone. What they didn't expect was that in the control group, where the breast cancer cells are just sitting in the test tubes and no estrogen had been added, they also multiplied as if the hormone had been added. And they later discovered that the manufacturer changed the formulation of the plastic test tube to polystyrene and found that the nonylphenol chemicals in the polystyrene plastic are xenoestrogens. They're synthetic estrogens that can cause breast cancer cells to multiply. So in the late 1980s, we started to get an idea that these chemicals could increase risk for things like breast cancer, and yet still to this day, nothing has been done about it. They can leach alkyl and nonylphenols. Alkyl phenols are commonly found in many cleaning products, which is why we're really strict about not having them in the Abode cleaning product range. And you know, they're something that needs to be avoided. Number 7, plastics, is every other plastic that doesn't fit into 1 to 6. So they include all your BPA-free plastics. We now know that bisphenol A is in polycarbonate plastic. However, the BPA-free plastic, the manufacturers are using BPS, bisphenol S, or bisphenol F. They are from the same family class of chemicals, and they're shown to be worse in terms of estrogenic effects than even BPA was. So your BPA-free plastics should be avoided. And as always, go back to basics. Stainless steel and glass are far better to store your food and beverages in. So all other plastics can include polycarbonate. They can include bioplastics. Some of these may be great. But they can also include acryl or nitrile butadiene styrene, which I know Nikon and many of the wellness filters use in their water filtration systems. You can often have these great water filters and they store it in these horrible plastics that can leach hormone disrupting chemicals, which is a problem. It's also used in various plastic baby bottles. Office water bottles often use polycarbonate, which of course can be a source of bisphenol A, which is another form of hormone disrupting chemical. And they can leach bisphenols. Health concerns, I've mentioned in 1987 the research by the cell biologists and breast cancer risk. There have been numerous documents on the impact of hormone disrupting chemicals from plastics and pesticides and perfumes and air fresheners on human health. In 2012, the World Health Organization published their report on the state of the science of the endocrine disrupting chemicals. That is a really important report to read as a building biologist. In 2015, the International Federation of Gynecology and Obstetrics released their white paper on hormone disrupting chemicals. And in 2016, the Tender Consensus Statement came out. Really important documents to read. I do go into that in detail in the Children's Environmental Health subject. Health concerns, genital malformations have increased significantly in Australia alone. Genital malformations in young boys have increased, i.e. where they've been born with undescended testicle or hypospadias, which is a condition in which the hole at the end of the penis is found along the penile shaft, not at the end of the penis, and that of course requires radical surgery. That's a problem because boys that are born with this deformity or undescended testicles have much higher rates of testicular cancer later on in life. Declining sperm counts. We know the average sperm count in males have declined by 50% in the last 50 years, and a lot of that they suspect is correlated to the exposure to hormone disrupting chemicals in pesticides, phthalates in perfumes, bisphenols in plastics, etc. Cancers, hormone disrupting cancers from the breast, endometrial, ovarian, prostate have been correlated with many of the chemicals that are known to cause hormone disruption. And of course, puberty, the age of puberty is declining. The average age that a girl used to start her period in the 1900s was 16. Now they're starting as young as 7. Average age in Australia is around 10.5 years of age. That is really young. The earlier they start their puberty, the greater the risk for breast cancer. We know childhood and adult obesity has increased. Infant obesity has increased. Infant obesity in children who've never passed any food in their lips, who've just been breastfed or bottle fed, the incidence of infant obesity has also increased, and they're starting to think that the exposure to these xenoestrogens or hormone disrupting chemicals during pregnancy at certain critical stages is causing the obesity. There's another theory that the reason why kids are becoming obese is because they're exposed to these chemicals, environmental chemicals, since the 50s and 60s, and pesticides. And as a result of that, the body's shunting the pesticides and chemicals into the fat to protect it, to keep it away from vital organs. So it could be a protective mechanism developed by the body to prevent the exposure to vital organs. An interesting theory. Metabolic disorders like type 2 diabetes, widespread infertility, retarded neurobehavioural disorders like autism and learning and behavioural disorders we know are skyrocketing. In the 1970s, about 4 in 10,000 children in Australia were diagnosed with autism. Now it's 1 in 35 between the ages of 5 and 14, according to the latest Australian statistics. It's just a pandemic. This is the report I was referring to by the World Health Organization. You will have links to that, you can just Google it. It will be discussed at length in the children's environmental health subject. The reason why this is important is because these chemicals don't react like other chemicals. At lower levels, that's when they have their worst impacts. So in parts per billion or parts per trillion, that's when the hormonal system in the body acts. It doesn't act when you get into high levels of chemicals. So the lower the level of chemical exposure, the higher the impact it has on human health, especially to a fetus and a child going through puberty. So an endocrine disruptor is an exogenous or external substance that alters the function of the hormonal system in the body and causes adverse health effects. We know until 7 weeks of age that the human embryo has both male and female reproductive organs. So whether it's an XY male or a XX female human embryo, it has 2 sets of organs ready to go. And if by week 14 a gene, the SY gene on the Y chromosome, sends a message to the male fetus to produce testosterone from the testicles, if that doesn't happen, that male human XY embryo will become a female phenotype, and she will have all the secondary sex characteristics, breasts, the whole lot. And the only time she'll know she's not a male, not a female, is when she tries to have children because she has no ovaries. Now, we're starting to be concerned that the level of hormone disrupting chemicals that the average pregnant woman is exposed to are altering these important epigenetic effects, which could have devastating impacts on human health, like fertility, early puberty, breast cancer, etc., and that's already happening. We know that over 1,000 hormone disrupting chemicals in everyday products, and this is why we learn about this in the air pollution subject, all the subjects we do throughout the course, but especially in children's environmental health, we'll focus on this quite a lot. So hormone disrupting chemicals are in the plastics, which I've mentioned. Polystyrene, polyvinyl chloride and polycarbonate are the main ones. Bisphenols, of course, in your cash receipts, in your tins, often they're lined with BPA. Phthalates, and of course cleaning products with nonylphenols. And many metals like lead and mercury are also hormone disrupting. Now I want to pass you on to Raphael, who's going to go into the advantages and the disadvantages of various types of plastics.
Plastics. Let's go, and you've just heard Nicole speak on plastics in quite a lot of detail. We're going to go through the advantages and the disadvantages and a rating, and then talk about plastics in a building and the materials that are used and all the disadvantages and advantages there. So very generally speaking, plastic is always the cheaper option compared to other materials. It is relatively durable and malleable. Some can be recycled, although as Nicole says, especially on a work site, you don't see recycling happening very much at all. You have to pay for bins, and there are companies that exist that come around to help with that procedure and put specific bins out for metals and plastics and so on. But it's very rare. It's very much an infant industry and not used a lot. But it can be done, and the industry does exist. Doesn't easily break, and it's very lightweight. So this is generalized in terms of plastics. If we look at a building, there are so many different areas in which plastics are used. I couldn't possibly cover them all. But the major ones that are of concern are obviously what Nicole touched on as well, is the water pipes. Water pipes, there's a lot of debates in terms of which water pipes are the best from a health point of view. Copper pipes, a lot of the time in the US, you will see building barges there pushing copper pipes as the healthiest pipe to use. If the copper pipe hasn't oxidized, if the copper pipe is stable, it has been cleaned out properly, doesn't degrade and so on, then copper pipe is a good option, particularly with hot water, because that's where it heats up. And then you can have issues. However, I've seen a number of cases, and I know Nicole has seen a number of cases as well, where the copper pipes have been a problem and they have degraded, particularly here in Australia with older homes where they earth to the copper water pipes. They had to by law, and there we find that the corrosion can often happen more easily, and then the copper pipes corrode and break down. Copper poisoning or high levels of copper are not a great thing to go through. So copper, I'm on the fence with copper. It can be a good material, but in practice, it often isn't a good material in terms of water pipes. Polypropylene and polyethylene pipes are what are used now as the norm almost, not PVC like in the US. They are probably amongst, in terms of water pipes, the most stable. Still issues because they run in hot and cold water. In cold water they'd be fairly stable, but in hot water we still might get issues in terms of leaching. So there's cross-linked polypropylene, there's polyethylene high density, and the good thing about the plastics in terms of water pipes is that they don't have to be welded on these days. Like when the lead pipes had to be Galva had to be had lead solder, and you had to weld joins, and there are all toxic metals involved in that and so on. These days with plastic pipes, there are all joining systems. So you get elbows and T-junctions and so on, and it's just easy click systems that are used to put all the water pipes together. So it's a hell of a lot quicker. And no glues, no solders, nothing like that, which were an issue with water pipes in the past. So, in my opinion, if you wanted to try and, if you were deciding on what water pipes to put in, remember that the water has come to your property through a myriad of different types of water piping along the way. So depending how close or how far you are from the reservoir, it has already gone through a lot of different kinds of water pipes, being asbestos, cement and concrete and galvan, all sorts of things. So by the time it arrives there, what it sits in your property, it's debatable whether that makes a big difference. However, you want to choose the best option that you can. Filters are very important. Nicole always says that you either put a filter in or you are the filter. So that is true. You have to decide what you want to do in terms of water quality. Water quality varies significantly amongst different areas and different states and different neighborhoods within different states. So, and varies during the year and the season and so on. So water testing can be very hit and miss. You can get a bit of an indication, but it's so variable. And there are very specific water filters that are for specific issues. So we're not going to go through that whole thing. And again, the water filters are often plastic, plastic water filter cartridges, plastic housings and so on. So the water will again go through plastic, which is a little ironic when you put in water filters, but it will take out an enormous amount of a lot more toxic substances potentially. So doing water tests helps, and it's good to do it because if you have heavy water, if you have heavy metals in water, high pH, low pH, whatever, you can get water filters that will fix those specific problems. So from my point of view, if you get very good quality pipe in terms of copper and you ensure that it's cleaned and so on, that can be used for your hot water pipes, and then probably a good polyethylene or possibly polypropylene used for the cold water. Or you just go polyethylene and polypropylene pipes with all the joiners and choose what sort of water filtration system you're going to put in. Again, very difficult to get away from plastics, even in the water filters. So that's in water pipes. That's a very significant part. There are also stormwater pipes, which again are not going to affect your water quality, but that generally are always PVC, have always been PVC, but now they produce, for the stormwater pipes, they now produce polyethylene, so you can get them. There are a couple of sources: Polypipe Australia, Matrix Piping Systems, and Advanced Piping Systems Australia, iPlex Pipelines, IPLEX, and Vinidex. So these are different companies that can potentially help out, because most people say they can't source these polyethylene pipes. Where do they get them from? They're not that common. But there are a number of companies that are producing those pipes now. That's an environmental thing. So obviously all this PVC pipe now you have, instead of PVC, you now have polyethylene, which is a hell of a lot better and more stable. So it is available, and you can do it. You can move completely away from PVC. All the Green Star buildings, LEED, all these green certification commercial buildings, they very much want to be zero PVC. So they source all sorts of plastic pipes that are not PVC, and all sorts of different parts and plastics that are usually PVC. They're very strict. You get a lot of points if you have no PVC in a Green Star building, for example. So water pipes, that's one issue. The next issue are window frames, where plastic PVC again. Window frames are very common, and some people like them because they say they have condensation issues with all the aluminium, which is probably the most popular window frame here in Australia, and the plastic is not as cold. It doesn't have such a high thermal conductivity. So sometimes you'll get condensation on an aluminium frame that isn't thermally broken, your standard solid aluminium frame, but you won't get that potentially unless there's a lot of moisture around on plastic. It's still cold, you'll still get condensation, but not nearly as bad as you would with aluminium. Of course, timber being a hell of a lot better. And of course, there are also frames that you can get that are composite frames, so that you can have aluminium on the exterior and you can have timber on the interior. So you don't have to have all the maintenance done on the outside, which is why people don't get timber. That's all aluminium, as hard as nails. And then on the inside, you have the timber, and that creates a natural, there is no thermal bridge because the whole internal part of the frame is timber. There is also an option, and if you have aluminium, you can have a thermal break in between the frames so that there's a little air gap. Again, sometimes often pieces of plastic that go in between so that there's that break between the external part of the frame and the internal, and you won't get that condensation. But in terms of plastic, again, PVC is a disaster. Nicole's gone through that in great detail. If you can steer clear of PVC, please. From an environmental point of view, from all the endocrine disrupting chemicals, when the heat hits it, it gets very, very warm. And yeah, there's a lot of chemicals that can cause issues there. So try and steer clear of the PVC, even though it does have the advantage of being cheaper, of having lower thermal conductivity than aluminium, and being fairly solid. And sometimes they don't look that bad. A lot of people actually like them. Where I'm talking to you again, I'm talking to you from the point of view where I have clients asking me to specify on homes. So it's often a toss-up. You hear about all of this stuff, then you come to build your home and you go, oh, that really looks terrible, or that's just too expensive, I don't have the money, so I have to do this. And there will be a lot of compromises that happen along the way. All we're here to do is give you all the information on the different materials, and you decide where you're going to put the money, where you can compromise and where you're not willing to compromise. Please don't compromise on anything to do with the glazing on windows and sliding doors. They are your weakest point in the building. So if you're going to put money into the home, please put it into the glazing, and that includes the frames, not just the glass, but includes the frames, because that is where you're going to get condensation issues. And that is where the heat hits those frames and will cause issues, for example, if you've got PVC. And that is what's going to insulate you as well. It'll be your weakest point. So the glass is often the weakest, but you'll be surprised people put in very thick, amazing double glazing in and have a standard solid aluminium frame, and the aluminium frame's just pouring with moisture. And they're devastated because they've spent so much money on the glazing, so much money insulating the walls and the ceiling and the roof and so on, and there they've got condensation in winter all the time on their frames. So please try and spend the money and don't compromise in that area. In some other areas, there are often compromises that can be made if they have to be made, but not when it comes to glazing in the frames. So my personal point of view is on frames, for example, to steer clear of the PVC and the plastic. Timber, I understand there's an operational energy, and that's another advantage with plastic. Everyone talks about embodied energy, and embodied energy is very important. However, the operational energy, or the maintenance energy it's also called, is often as important, and sometimes people say more important than the embodied energy, because there's a hell of a lot more energy that goes into maintaining and operating a particular material than what went into mining it, manufacturing it, and getting it to site. So plastic, you can put it in, and that's one of the arguments for plastic. You can put it in, it works, you don't have to maintain it at all. Whereas timber, you've got to constantly get oils and put it on. So it's brushes then get into the waterways. It's the oils, it's a production of the oils, it's production of the tin in the oil. It goes on and on and on. So it's a very valid argument in terms of maintenance or operational energy. But still don't go near the plastic frames. Timber, you can either go solid timber, or I'm quite a big fan of the aluminium composite frame with the timber inside, because aluminium again has a very high embodied energy, obviously, but when you put it outside, it may last 100 years plus, and you don't need to maintain it at all. There's, like plastic, there's zero upkeep on that, well, close to zero unless it really degrades badly, but very little, if any, upkeep on it. And then timber on the inside, so you've got that breathability, you've got your natural thermal break. That would be my advice if you're considering PVC in the frames. So the water pipes, we've spoken about plastic. The window frames, we've spoken about plastic. Other areas that might have plastic, there's so many. All of your light switches are plastic, the covers, all of the PowerPoint are plastic, your cabling's all wrapped in plastic. There's enough plastic around the home. It's very difficult. There aren't options in terms of cabling getting away from plastic. You're always going to have that plastic in the cabling. But in light switch covers, of course you can make a difference. Just be a little bit different. There are really nice timber light switches. Sometimes the kids make them. They can draw up a little template and they can do really funky designs, or just plain ones. You don't need to go out and buy the PVC plastic covers, because again it's just increasing the amount of plastic and off-gassing in the home. So that's an issue. All of your glues will have it. Plastic and PVC, especially if you have PVC. One of the most toxic substances in building a house is that PVC cement and glue, which is actually used to basically hold those PVC pipes together and glue them together, and so they're watertight. I've had many people call me on all sorts of issues trying to come up with a better solution. That's as toxic as it gets. And unfortunately, the plumbers that deal with that a lot often have real health issues. So it's in a number of glues and resins and so on, even caulking, slicking, everything that you use around the home to seal and glue and so on will have these plastics in. So wherever you can cut down on plastics, like in the window frames, please do so there, because there'll be other areas where it's just impossible to cut down on plastic. And therefore, when you're rating it, you've got to give it some kind of rating, because it's kind of necessary to be used. It has to be that you don't have another choice. So it has to be used even though it's not a great product. Another big one that's used, the only time that I will ever say that plastic is an option is when it comes to the bulk insulation. The polyester bats, I think when they are manufactured, they're a real issue because they are thermally bonded, so they are melted together, and there's a hell of a smell, as there would be with melting plastic. It's fairly stable. In terms of VOCs, I don't pick up very many when it comes to the stable product once in its finished form. They have advantages in that if you do get water leaks in the roof, they will not support mold growth. Mold will grow on anything, but it will grow a lot less readily on plastic bats than it will on wool or the rock wools and glass wools and all the other types. Earth wool is a very popular product from Germany. They say they're non-toxic binders and so on. It is glass fiber mixed with wool. I just don't like the glass fiber. It's horrible to work with. But earth wool is probably a good option. But polyester also doesn't collapse over time. So that's another good thing about plastic. Because it's so persistent in the environment, your insulation will be there for a long time. They guarantee it for 50, they say it'll be 100, I'll tell you it could be there for 200 years. The plastic doesn't break down very, very, very slowly. So whereas everything else, and the wools and the so on, have to have these toxic binders to hold them together. They're not thermally bonded like plastic, so you get complementary all these chemicals. You get fire retardants. Plastic meets the fire retardant specs already, so you don't have to add fire retardants onto them. Doesn't have to have pesticides put onto it. A lot of them are treated for pests because they're up in the roof and that's where pests are. So the amount of treatments on insulation bats is something worth thinking about. And this is what you have to weigh up. You can talk about plastics just in general, but when it comes to every product in the building, you have to weigh it up with the other options. And that's why I'm going through the three main plastics in terms of the polyester bats for insulation, the window frames, PVC, and the water pipes. And then there's a bunch of other little bit of stuff, and the glues and resins. But those are the three where you can decide what you want to do. But there are a lot of advantages to polyester bats being used for insulation. So disadvantages of plastics. There are many, but obviously the most significant, which Nicole's gone through in detail, are the adverse health effects related to all the various plastics. And it's obviously an environmental catastrophe in terms of the oceans. We watch all this. We know omega-3s fish are the greatest source, and it's all driven with fish. But when you eat fish, you eat a lot of other things that, besides getting your omega-3s, you will get an enormous amount of endocrine disrupting chemicals, potentially differing amounts of mercury and so on. But yeah, we need to control the plastics. It's a war that I'm not sure if we're ever going to win, to be honest. But yeah. So 2 out of 10, I mean, you just want to give plastic 0, of course. It's a revolting product, but you have to give it some form of credit in that it has to be used in some circumstances. There's no other choice in terms of a home. And if we can get stable, non-leaching plastics like the high-density polyethylene and so on, that is what's very important, and we give it some score, and the polyester bats. But otherwise, we try and go for anything else that we possibly can.